I originally intended to start this episode with a review of the road building tool in the original game, New City. And I was going to go over, how intersections between roads work. But there's a serious problem here, and it's why the original game is kind of unplayable. If you look here, look at that. Now this is on a map with no buildings, no neighbors, nothing going on. I could pause the game. I notice when I zoom out, I get much better FPS, although still not great. I mean, for a grid with nothing in it, there's nothing in this grid, so I should be getting 60 FPS. Why aren't I? And I have some theories about why, but I'm not really going to investigate what went wrong with the old game. But this has made me feel like I really need to take performance seriously from the get-go if this new game is going to be successful where the old game wasn't. So maybe we'll come back to this for a feature review. Maybe I'll just tolerate the FPS. But man, this is terrible. I don't know how it got so bad. So I'm taking a look at the new game, the code for the new game, particularly related to OpenGL, commenting out different parts, trying to figure out where I can get performance benefit, what's causing me a performance cost. Okay, the first thing I'm going to do is undo. Where did I put this? Well, we must know when we're creating the texts. There it is. So height. So let's make a variable here. 32 FB width. Well, let's do this after we get the values. Width times 1.0 F. Change this to height. And then B width, FB width, height. Or 32. Actually, I want FB width equals handle.width times 1.0. Okay, let's see if that improves things. Oh, we might want to get some information. This does look faster, though. So inconsistent. Okay. What if we just don't draw anything? It's still really inconsistent. Well, these are good values, but why is it so wild? Maybe that's just OBS? I'm just going to turn off OBS for 1 minute and see if I get a different result. Okay, I can definitely get a big improvement by just removing some dead code that I wasn't even using. So I'm glad that I looked here. And I don't really want any of this related to this SDF here. That's for an old version of the UI that I am just not using anymore. Let's see. Okay. GL error, invalid value. Terminal color undefined. Terminal color. Equals render color. Although, let me actually do this. Render color. Much, much better. Let me just get this failed to find uniform. I think it's this one? Yeah. I should probably generalize this pattern. Look at that, I got a huge performance benefit just by removing some dead code. Now, I don't know why it's so wildly inconsistent. Let's see. I don't think I use any of this here either. So let's just not send it. Or this. Or this. Turn uniforms. Oh. What do we need in position for? I guess we need the resolution. Okay. I managed to mess up my undo, so I have to go. I don't think we need this character data, though. Now what's it on about? GLR. Okay. Huh. Fine. Now can I delete this? Yeah, okay. Alright. So that's really good. We got a big performance improvement. Wait, what did I change in? Oh, let me not commit everything. Let me just commit the parts that source/interface. And let me just read what I changed. So deleted a bunch of stuff. And set the frame buffer to the same resolution as the monitor. rather than 4 times the resolution, which I was trying to do kind of some super sampling, some anti-aliasing, but it looks like I'm not going to get that. Now another source of performance issues is I was trying to do some fancy text for a nice UI, but looks like we're not going to get that. There's, just going to be, the performance is not going to work. Where did I put it? Here it is. Okay. Oh. I have to actually display it. Wait. So why aren't I seeing anything? Oh. I'm in the wrong game. Here, I want to re-enable the UI and see if we get any performance hit there. Yes, we do. It's a big performance hit. Let me look at this, because it looks like there's some frames. I guess I don't see those frames because I'm, they go by so fast. Well, that's interesting. Still getting these very inconsistent frame rates. It looks like every 4th frame, or maybe every 3rd frame, it's just really, really fast. Well, it's not. It doesn't look like a terribly regular pattern. But, except for these 51 frames, there's a 50 frame. If I could get it consistently above 60, I would be pretty satisfied. Oh, look, here's a 39. Well, that's troublesome. Let's turn on some more of the graphics. And I just want to know, does this feel like a smooth frame rate? It feels alright. The cursor movement is pretty good. The camera movement needs work, but I think that that's not really a frame rate issue. I think that we need like more easing or something like that. Now I notice that we just never see higher FPS here. Now if I turn off the UI here, what does that do? That does feel a bit nicer. Yeah, okay. So definitely the UI is the problem. So I'm just going to disable the UI for now. And I'm either going to use an off-the-shelf UI, or I'm going to re-implement the custom UI in a way that makes sense, in a way that is can be done in a performance way. These frame rates really aren't acceptable, for a game in which nothing is going on. So let's just eliminate everything that's happening, and this should just be a raw loop, in theory. I guess I have to maybe I have to do the UI so that I get the printf. Okay, so I get 60 bazillion frames per second, looks like. That's good. Well, it's interesting that it can do the loop. Oh, that's funny, because nothing clears the tasks. That's a more significant drop than I would have expected, but not that serious, really. Now I'm able to get the escape key. It's kind of funny how much it drops. I mean, it's not in the range that we care about, because, I mean, if we could keep this much FPS. So, this task is not doing anything, so kind of interesting if that trend continues. No, looks like it's an empty task doesn't seem to have much of an effect. I'm going to try it without draw, and then with render, but without draw. So it looks like draw is not doing anything, which is not surprising, because it's not doing anything. Now render is probably going to take us down a lot. Yes. So, if we look in the actual render code, now we can try to cut off certain parts and see what is driving any performance issues. So, I'm not sure how much of this I can just comment out, but I can try. Stuff related to the shadows in general, I think, is kind of, I can eliminate, because the shadows aren't working anyways. That does seem to give us a little something extra. Let's see. I think we could remove some of that. It's very confusing which parts relate to what parts. We can disable this part. Okay. So I think if we disable this part, then the whole rendering system won't work. And it's possible that OpenGL is able to simplify some other things. So by not doing that work, then it might, save a lot of time. But it is interesting that it is kind of the benefit that we're looking for, although we're not getting stability. I don't know what we have to do to get frame rate stability, or if that's even something worth trying to get. Okay, this part is kind of done in the camera. So we can delete some of this dead code here. Looks like there was a previous optimization here. I'm not sure if that optimization is relevant. Look at this, it's wildly inconsistent. I kind of want to know what's driving these wildly inconsistent frame rates, because, let's see. We just comment out a lot of things here. How much can we comment out without it crashing or whatever? Well, the more I comment out, the faster it gets. It would be confusing to uncomment this because some of this code was previously uncommented. So probably what I'm going to do is just discard the changes in get. So I can kind of just bulk comment some stuff out. Because what I'm curious about is, if I just disable basically all OpenGL related stuff, what kind of frame rate do I get? Okay, so this is kind of what we expected. It was the same as we were getting before. Now, if the only thing that I do is swap buffers, what do I get? Whoa. That gives me a headache. Okay. And we can see that we get inconsistent frame rates, so I'm going to blame this on NVIDIA drivers. And maybe I'll do some Googling, and maybe there's a general solution to this. I noticed that the frame rate is kind of close to my monitor's frame rate, which is 165. So a lot of times it gets close to 165, a little bit under, a little bit over, but then in some other frames it's just like way off. Well, I wonder if what's going on is, okay, so like it does some frames that are kind of close, and then this frame is just way slow, so then it does the next frame really quickly so that it can kind of get close to a cadence. That maybe that's what it's trying to do. So you see, like, there's a slow frame here, and it does the next frame really quickly. But there's some internal mechanism that's trying to keep a cadence, but occasionally you get a really slow frame, and then it follows it up with a really fast frame. Interesting. Well, then let's uncomment some stuff and see where we can get. That looks about the same. Now this one, I think, is going to be like a real driver of bad frame rates. No, actually not. Of course, we don't load the program. I don't know why this one says render depth text. is it's not rendering anything. Now write some draw commands into a buffer. That's okay. And we noted that there was this potential optimization here, which we might look at. So, if we think that we can disable this since we're not doing the shadows anyways, that kind of makes everything look like it's in shadow. That's interesting. Well, this is an interesting way of testing to make sure that our shadow map is covering the entire scene, which obviously it isn't. Whoa! Is this real? Why are we getting 30 FPS here, but then if we turn the other way, what is it that causes it to go down so much? Because we're starting at this kind of inconsistent, but like most of the time we're getting better than 60, but it is quite inconsistent. And you can see that we do get less than sub 60. But then, what is it required? Maybe it's because I'm creating so many meshes. Huh. It really seems to, the FPS just seems to go down a lot when I move the camera or something like that. Or maybe it's just continuously going down as the program is running. Huh. Well, let's let it sit for a second and just see. Is it the camera, or it must be just something in the memory or something building up? That's weird. Let me just look at the code here. The test mode code related to the road building. Because what I want to know is, right now we're in a state of 0 control points placed, right? I think. And so it shouldn't be generating new meshes every frame. And yet it is going down. Oh, that's interesting. Now it's terrible. What is going on here? That's wild. And this is, maybe it's so slow because it's creating a new mesh every frame. Okay, so it must have number of control points placed as 4 when, yeah, okay. I think I understand what's going on. And then, because we're creating a new mesh every frame here, that's just slowing things down a lot. Kind of surprising. So I think that what's happening is when we're adding new meshes every frame, then it's probably here that we're, wait, no, not there. Yes, the VBO. So the VBO refers to the mesh data, basically. And in this game engine, we're using one mesh to represent all of the models in the game. And that allows us at the bottom to do this GL draw arrays. Not this far down. Here we go. GL multi-draw arrays indirect. Because these commands are based on this big mesh that contains all of the meshes. And it has indexes into that big mesh. And up here, where was it? With the VBO, we set up this mesh. Well, we do a buffer data, but we could do a buffer sub data. I think that we need to do buffer data in order to grow the mesh, or in order to grow the array. But we could, allocate twice as much to the mesh. Tell OpenGL, hey, we're going to make a mesh this big, that's twice as big as we actually need. And then we only have to update it, every once in a while, logarithmically. Okay. The next thing that I'm going to do is look at this function, GL buffer data, and ask, can we improve the performance here? Because I think that this is a big driver of the issue. In fact, I'm just going to test this right now. So, click, click. And what did we get when we had... Oh, maybe it's not so bad at the beginning, but I think that it gets worse. Yeah, if we wait a minute here, it'll get worse. Boy, it does seem a lot better, though, already. This is definitely more playable, even though nothing's really occurring yet. Okay, now we're getting back to the low FPS range that we were before. And this will continue to go down. Because what's occurring here is every frame we generate a new mesh for the road that we're building. Well, you can already start to feel the frame rate. I don't know if it'll show up on video. It's a 30 FPS video. So you might start seeing the effects on video now. And this GL buffer data buffers I'm going to call it the Uber mesh. So the Uber mesh is the mesh of all of the meshes in the game. And it's loaded at once. And it's only loaded if the mesh changes. But of course, we're adding a new mesh every frame. So it has to rebuffer all of this data. And so I'm going to do two things. First of all, I'm going to make it so that we can make a temporary mesh. And that alone will fix the FPS issues. But then I'm also going to look at making it so that we can do GL, I think it's buffer sub data. And it has a different API. In fact, we might use it somewhere here. Well, we have it commented out here. So this comment was kind of an example of what we would do. Oh, I actually attempted this optimization before, so we're just going to reattempt it, basically. GL buffer subdata. Yeah, so we're going to keep track of the size of the VBO separately from has the VBO changed, because that's going to become separate concepts. Okay, let's get to it. So I'm going to start from the front, because I think that ends up creating a better API. Write the API that kind of says what you want to say first. And then figure out the algorithm that implements that thing. So, where do we create the mesh? Oh, shoot, I'm in the wrong file here. Test mode draw. Here we go. So, procgen curved road. So every frame, this is generating a new mesh here. So, here's what I want to do. First, I want to go into Spline and change the way that this one works to use a mesh builder. And I'm just going to look at how I did it in procgen.h so that I can do it in a consistent way. Yes, I used a pointer to a mesh builder. And then in spline.cpp, procgen curve spline, and it's a mesh builder. B, and we're no longer returning void. So we don't need this B here, although we do have to check and change all of the dots to arrows. Here, and then this one is going to change. Actually, maybe that one is just omitted. Okay. And then we delete this line here. And now procgen curve road just takes a pointer to this mesh builder, and then we can use the mesh builder to create a temporary mesh instead of a regular mesh. Now we're going to have to change a couple of places. Well, okay, maybe we could do both here. Because then we don't have to change some existing code. Where were we? We want spline.cpp. Okay. And all we do is make a mesh builder B. Yes. And then return b.store, I think it was. Now we don't have to change any code, I don't think. Did I make a change somewhere else? Oh, I left a piece of code in here. Actually, we don't need that. That was just for demonstration purposes. Okay, everything works the same. Next, in source interface mesh.h, store temp mesh in spline.cpp. Okay. I said I was going to type out the interface that I wanted first. So instead of getting a mesh here, we can do a mesh builder B. It needs to be an ampersand B here. And then we want to say, or we want U32 mesh to equal B dot store temp. And then in mesh builder, .h, store and store temp. Now, a temp mesh will be destroyed every frame. And at some point in the future, we might talk about like a mesh that could live for multiple frames but then be destroyed. But for right now, it's just simpler to make everything destroyed every frame. Maybe we can make this a Boolean then. And we'll make a default version that just assumes that it's not temp. Now, I think that this is going to be, see, this is why you do the API first. Or, well, let's do it this way, and then maybe the store with the Boolean would just be used internally. So I think that's going to be clear from the API. If we just have like this random true here that's passed to store, then that's kind of unclear what the hell is going on. Okay, where were we? So now we have a store, and then we want to store temp. U32 mesh builder store temp. There we go. And this one will just be used internally. We could make it private, but I don't really believe in making things private. I just think it's unnecessary. And now, the temporary meshes don't do anything yet. Store temp mesh. I don't know, that Boolean is going to be there's this argument about clean code and like how to write your code, and I certainly don't think that my code is any good, but the clean code guy, who in a way he's actually kind of reasonable. I don't agree with him on a lot of his takes, but he has some points. He says don't pass a Boolean to a function, that it should be two separate functions. Which, if you think about a function like this, because it's just going to be the same thing here. And actually, I think... Oh, something has to reset the temporary meshes at some point. Because what I was going to do is have a U32 last non-temp mesh. And then somewhere around here, either at the beginning or the end of the function, yes. And then we might have a void reset temp meshes. Which, okay, let me just look at how I implemented this here. What is this unordered map doing? Okay, so that's for loading a mesh from a file, and it's just deduplicating. Which we might have a more sophisticated asset loading system in the future. But well, maybe this wants to be... Is this the index? Okay, so there's multiple indexes going on here. There's the index into this array, which returns some other index. Yes. So this is a relation between a mesh index and part of the mesh data list table. So last non-temp mesh needs to be okay. This wants to be +1. So we're just kind of trimming an array. Yeah. So let's run this. Okay. That looks good. Let's open a road, and then I'm gonna take a look at some things, and we'll look at the FPS in a second. So right now I'm not resetting the temp meshes. So this really shouldn't make any difference in terms of the FPS. We are setting some of the meshes as, sorry, not here, test mode. Here we're storing as temp and assuming that that Boolean goes through. Now if we look at the FPS over here on the other side, we are starting to lose some FPS. So we set things up, And now we're going to see if we get any performance benefits. So we want to call reset temp meshes here, and then store the new temp mesh here. Set temp meshes was not declared in the scope. I think we need mesh.h. Okay, doop, 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 doop. And we'll leave this row open for a second and see, do we get anything in terms of the FPS here? Let's see. Let's get some printf debugging, and we can compare and contrast how much data we're sending here. So printf data, let's call it VBO data size. We are still losing some FPS here, so that didn't solve the problem. So let's see how our VBO size is growing. It is growing over time, which is consistent with losing FPS. Not surprising. It grows quite quickly. Almost seems like it grows exponentially. That is weird. Oh, that's interesting. It's still growing even when... oh, okay. Now it's not growing. But now if I open a new one, now it is growing. And we're getting that 25 FPS. So let's take a look in mesh.cpp and do some printf debugging here. Did we not call it? I thought that we were calling this every frame. Reset test. Oh. Hold on. I did this in the wrong place here. This doesn't want to be a temp mesh. U32 mesh equals... Yes. We want to do this somewhere else in the update. Where did we do it? Proc gen curved route. This button callback and then draw. Okay, so here's where we want to do this. Store temp reset temp meshes. Okay. Whoa. Okay, hold on a second. Let's not reset them. Ah! Okay, that part is fine. Okay, let's go back to resetting them. But let's look at... Yeah, I want to look at this resetting temp meshes printf. Whoa! Okay. So we're not creating any other meshes. Surprising that there's only 3, actually. Its end keeps increasing over time. Okay. Huh. Okay, let's look at this again. So I think that if there's some implicit code that works like this, store mesh, and it stores a non-temp mesh, and then it stores a temp mesh. This is just example code here. So it stores a non-temp mesh in between storing 2 temp meshes. Then this function would have to rewrite this array, or these multiple arrays, to sort out the temps and non-temps. And I probably need to write some tests for this. And equals... Oh, okay. Well, that's interesting. Okay, so at some points, we set the non-temp... What? Wait a second, what happens at the top here? Let me trip here. Let me see if I can do this. And I think that's in our error. Or our assert. Slash data slash r assert.h. Trip. Oh, okay, so I just have to make an assertion. I can't just... I didn't export the trip. Wait, what did I just do here? I need that function, or I need that import there. And here, instead of saying trip, I'm going to do r assert. I don't think I even have to provide any variables. I just want to go to the debugger there. I think I go to debugger. Will you just let me go to the debugger? Why did I write the API this way? Okay. Setting last non-temp mesh to 2, setting it to 3 after storing 3 meshes. Okay. Resetting temp meshes. Oh, okay, so maybe this one. Okay, so maybe it was right about like the +2. I'm not sure how AI figures this stuff out. No, let's get rid of this part here. Well, um, okay. What if this plus is 1? This is +1, and this is +2. That was what the AI gave us, I think. And the AI was Copilot. Okay. Just out of curiosity, does this one want to be a +1 or a -1? Definitely not. Okay. Okay. Now I think I see the next problem, which is bool mesh VBO buffer dirty equals false, and then basically every time we store a mesh, mesh buffer dirty equals true. And I guess it also will occur when we reset. Although that might not matter, but it seems like a good thing to do. And we'll say that it's dirty when it's initialized as well. Source/interface/render WinGL. So I was thinking that I was gonna take this section here and put it into a function that lives in mesh.cpp. I'm actually going to put it at the top. So void, there. We'll comment it out here. And buffer meshes. And then we have to put this into the header. And this is kind of part of an attempt to break up this giant function render, which, as you can see, is kind of a battlefield. It's very complicated, OpenGL stuff going on. And trying to break it up into some functions might make it more manageable. So I wonder if check OGL error is a public. Yeah, change word VBO buffer dirty. Then we need, what gives us OpenGL actually? Or, I've tried to do this in such a way that OpenGL is not exposed. Is not exposed as part of the .h API. So what I can do is I can move this to here, and then here. Although yes, okay. Okay. Bup, 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 bup. Okay. And now that all works correctly, but we're still, okay, here we do or, yes. Great. Very cool. Now, did I get it right? Oh, look at that. Okay. VBO data size is a constant size. It looks like it's small enough. For right now, it's small enough that we don't have to do buffer subdata. And it stays consistent. That feels really good. It's going to be really nice. I'm just going to leave the FPS there. I think we're confident in some of the stuff. We don't need to have so much printf debugging right here. As programming in JavaScript, and JavaScript has the console.log shows you the file and the line number. And I have that in the new city code base because I used some library for the logging. So maybe I'll bring that library back because that was pretty good. I'm going to have to stop this to actually see the FPS. I guess I can do this here. We got an 80 here. Yeah, it doesn't look like we're losing frame rate, but the frame rate is still very inconsistent. Look, sometimes we get 400, sometimes we get 65. But at least we're getting mostly above 60. Let's see, I've removed some of the printf debugging. Continue to leave this open. Go ahead and make a commit. What was our last commit? Okay, great. Temporary meshes. Let me just clean up one thing before we go. The shader. I think this is rendered.frag.gsl. Since we're not using the shadow map, we'll and now I think we'll get something complaining about. Oh no, we don't. But now we don't have the shadow map. We'll turn it back on and fix it and make sure that we can get good performance with a shadow map. I'm gonna try to keep some rules like greater than 60 FPS, close to 165 FPS, and if we start to drop below those margins, or if it's too inconsistent, then I'll go in and I'll treat that the same as I would a crash. When the program crashes, I have to treat that as a something that breaks the game, that ruins the experience of the game, and it's the same for performance. That's my attitude going forward. This is a lot nicer to play with when the performance is nice and consistent. To be honest, it's still not where I want, but I think that that's more my computer. And I'll have to take a close look at that.